So a normal distribution is simply a bell-shaped curve it has no skew, as you would see on the picture on the right. It has no skew. And it has two parameters. One is the mean, mu. Second is the variance, sigma squared. So if the variance is sigma squared, we know the standard deviation is simply the square root of the variance. And the population version is simply mu and sigma. If we are talking about a normal distribution that has been that is obtained from a sample, we denote the mean by x bar and sigma squared by s. So this is the population case. And for the sample case, we simply have x bar to be the sample mean and s to be the sample standard deviation. Uh-oh. So if we have a normal curve, that's what we have here, that it satisfies some properties. I already wrote a few. Doesn't matter what type of normal distribution you have, it's always represented using the mean and the standard deviation. So mean is x bar. I'll just go with the sample notation here. So x bar is the mean, which is right in the middle. So the cumulative probability below x, that's the x-axis. Maybe I should use a different letter so that you understand things better. The cumulative probability below a i.e. which is simply the probability x is less than or equal to a, corresponds to the area under the curve. Up to a. What do we mean by that? So I'm going to arbitrarily pick a value, a. Let's just say that a is right over there. And I would like to find the probability that x would be less than or equal to a. So that simply would correspond to the area under the curve below A. Now, if this area was a square or a rectangle, it is easy for us to find. But what we have is a curvy area. It's not a rectangle or a square. So if we want to find the area, we have to rely on the calculator. So we will use the calculator to find this cumulative probability. But the key thing to understand here is if we're trying to find the probability x less than or equal to A, that corresponds to the area under the curve. Let me copy this here from I guess it's not working today. Wait. I'll just write the properties. So the area below the mean is simply 0.5. So what do we mean by that? Here we have the middle line, which is x bar. The area below the mean is simply 0.5. So let me move that line and so all of that area that I will find below the mean under the curve will be 0.5. Likewise, the area above the mean would also be 0.5. So if we found this area right here, so that value will be 0.5. This is something we have looked at when we did the empirical rule. So probability of x less than or equal to x bar is 0.5. Probability x greater than or equal to x bar equals 0.5. So the area below the mean is 0.5, area above the mean is 0.5. So in total, the area under the entire curve is 1. And since these are probabilities, we could either call it as 0.5 or 50%, 1 or 100%. Now that we typically like to stick with decimal values. We all know that we can convert an observation from a normal distribution to a z-score. So suppose a sample has a normal distribution with mean x bar and standard deviation S. Then the z-scores of an observation or of observations, I should just say score of an observation can be obtained using that formula. Z is equal to x minus x bar divided by S. So the observation here is x, z-score is the z value that we find, and S is the standard deviation. So So if I start with data that has a mean, x bar, and standard deviation, which is S, and it has a bell curve, we already know that this is a normal distribution. And if I convert them to z-scores, so the data is converted using the formula x minus x bar divided by S. So I take every observation in the sample, use it in the formula, and I convert it to z-scores. And the nice little property is all the x values here now become z-scores, so they end up becoming z values. And the x bar that we started with in the original sample would now become 0. The standard deviation that we started with S now would end up being 1. So on the left-hand side, we have a normal distribution with mean 0, mean x bar and standard deviation S. When we convert it, we end up getting another normal distribution. And that is going to satisfy all properties that the one on the left would satisfy. But the only difference here is we don't call the normal distribution of z-scores as a normal distribution. Rather, we call it a standard normal distribution. If someone refers to something as refers to a distribution as a standard normal distribution, then by default, it is going to have a bell curve. The mean is 0, the standard deviation is 1. It is implied. This would imply mean 0, standard deviation mu is the mean and sigma is the standard deviation. So the mean would be 0, standard deviation is 1. This would simply be the normal distribution of z-scores. I made an error earlier. That should be x bar, my bad. And that the one on the left is normal distribution. of any sample, and that sample would have a mean x bar, standard deviation s. So here we have three problems where we want to find the total area under the standard normal curve to the left of negative 2.94 or to the right of positive 2.94. I always suggest that drawing the curve out would help. So we're going to start with part A. And since it is given in the problem that it is a standard normal curve, by definition, this would imply that the mean mu is 0 and standard deviation is 1. So the mean is going to be right in the middle, and negative 2.94 is probably somewhere over here. Positive 2.94 is probably over there. And we want to find the area. So in terms of a notation, this is probability uppercase Z less than or equal to negative 2.94 plus the probability X greater Z greater than or equal to 2.94. Now, I used addition rule to find the probability, and the third part is 0 because a number can't be less than or equal to negative 2.94 and greater than or equal to 2.94 simultaneously. So how do we find this using the calculator? Press second bars, the button right next to clear, number 2, and press negative second comma 99. That stands for negative infinity. So negative E99 would mean negative infinity, comma negative 2.94, comma 0, comma 1. So the first number is where the area started. So the area that I shaded started somewhere on the left-hand side. That left-hand side is negative E99. The area where it ends on the left is negative 2.94. So that will be the second argument. On the we can get to the right-hand side in a bit. The mean is 0 and the standard deviation is 1, and those would be the last two arguments. So the standard syntax to find this area using your calculator is normal CDF and I end up getting a value of 0.0016. Note that the normal curve is symmetric. So whatever you see on the left-hand side, whatever area that we see on the left-hand side will be the same on the right-hand side, as long as the number that we're looking at is the same on both sides. So we have negative 2.94 on the left, positive 2.94 on the right. So the area to the left or below negative 2.94 will be the same as the area to the right or above 2.94. I'll put that remark here. Now, if you have a newer version of TI-84 calculator, the syntax is pretty much the same, but the way that they would take input is slightly different. So the screen would look like lower, upper, I believe it's mu and sigma. So all you have to do is enter lower to be negative E99, upper to be the Z value, in this case, negative 2.94, mean is 0, standard deviation is 1. So let's try finding the area above 2.94. So same process, second, vars, number 2. This time we're looking at the right hand side. So we are going to start at 2.94 and the area is going toward positive infinity. On the left hand side, it started at negative infinity and we got closer to negative 2.94. Here on the right, the area starts at 2.94 and it's heading toward infinity. So 2.94, comma, second comma would bring the E up, 99, mean is 0, standard deviation is 1. And you can see that probability that we have 0.00164 is the same value that we had previously. And they are the same because we are looking at negative 2.94 and positive 2.94. So the probability of Z greater than or equal to 2.94 is 0.0016. So for part A, the answer would simply be the sum of the two. So the answer is 0.0032. So part B, they want to find the area to the left of negative 1.68 or to the right of Z is equal to 3.05. 0 is right there, 3.05 is probably right there. And on the left-hand side, we have negative 1.68. And that is the area on the left-hand side. You have to keep in mind, by drawing this picture, the bell curve out, you can sort of get an idea about the answer just by looking at the area that you shade. We already know that the area below the curve is 0.5, area above the curve is 0.5, and the total area under the curve is 1. So you can look at this picture and sort of gauge as to what the answer could be. On the left-hand side, the area definitely has to be below 50%. The area on the right-hand side has to be very, very tiny. So the answer that we're looking for has to be less than 50%. So let's say if that is true. So probability to the left of negative 1.68, it is simply the area below negative 1.68. Second vars, number 2, since it is the area below, we start at negative E 99, end at negative 1.68, mean is 0, standard deviation is 1. That value is 0.0465. I'll just round it to the 4th decimal place. The area above 3.05, we will simply start at 3.05 all the way up to infinity, mean 0, standard deviation 1. And that value is 0.00114. So the area below or to the left of negative 1.68 is 0.0465. Area above or to the right of 3.05 is 0.00114, which I can round it to 0.0011. So the answer in this case would be the sum of the two. So the final answer is 0.0576. So before we proceed, the answer to the previous one is 0.0476. It's just bad addition on my part. So part C would like to know the area below negative 0.88. Or the area above or to the right of 1.23. So 1.23 is probably somewhere over there. So that is the first probability, and that would be the second. And we just have to find and add them. So second vars, to find the area on the left-hand side, we start at negative E99, all the way up to negative 0.88. The mean is 0, standard deviation is 1. So probability Z less than or equal to negative 0.88 would be 0.1894. Probability Z greater than or equal to 1.23. Similar process, but we're going to do it on the other side. So second vars, number 2, we start at 1.23, go all the way up to second comma, that will give us the E and 99, mean 0, standard deviation 1. And the answer is 0.1093. And all we have to do to find the answer is to add those two values because of addition rule. And mind you, that the two areas that we have are disjoint. So that is the reason why the probability that both of them would happen simultaneously is 0. So the event here and the event there and every single problem that we did, all of them, the events are disjoint. So here we have a whole bunch of problems, but it is dependent on a random variable that is normally distributed. but the mean here is 50 and the standard deviation is 7. And you can see these problems, some have greater than, some have less than or equal to, greater than or equal to, and so forth. So the purpose or objective of this exercise is to remember this remark. The remark is the probability x less than or equal to some number a is the same as probability x less than a. It's very, very important. You can't do this with a binomial distribution, but you can do this with a normal distribution. In other words, the equal sign does not matter. So I'm going to do the first problem, which is greater than. I'm going to use the given information, which is normally distributed with mean 50 and standard deviation 7 directly in the calculator. And then I'll show you what would happen if we converted to a z-score and then found the probability. We will end up getting the same answer. Going back to that particular curve. So the area that we find using the original data, for example, if I found an area there, the corresponding z-score would be about the same location, and your answer must be the same. So when you do this in practice, you don't necessarily have to convert it to a z-score to find the probability. This practice of converting to z-score and finding the probability was done a long, long time ago before calculators became commonplace. Now that we have calculators, we really don't have to do that approach and look into the table that is in the back of your textbook. It's not necessary. So the first problem, it's 35. So the mean is 50. The standard deviation is 7. If that is the case, 35, with experience, you would know exactly where to draw these lines. And I would refer you to look at the empirical rule of normal distributions. That would help you as to where to draw these lines. Experience tells me 35 should be somewhere over there. So what we want to do is we want to find that area. Oh, sorry. Greater than, so we have to find that area. Even before we start the problem, I know something about the answer. The answer has to exceed 50%. It is obvious because I know the area above the mean is 50. So the answer definitely has to be over 50%. Let's see if that is true. So here, I'm going to do it directly using the sample information. So second verse, number 2, we start at 35, we end at E99, the mean is 50, the standard deviation is 7. So I'm using the data directly. And that gives me 0.9839 as the answer. Now, if I converted it to a z-score, the mean would now become 0. The standard deviation would become 1. We just have to find the z-score corresponding to 35. We know the formula for z-score is x minus x bar divided by s. So the z-score corresponding to 35 would simply be 35 minus 50 divided by 7. And that gives us an answer of negative 2.143. So if 0 is in the middle, negative 2 is probably going to be over there. So negative 2.143, because that is the z-score that corresponds to 35. Now we have to find the area above. Negative 2.143. So in your calculator, we would be using the same function. Second fast, number 2. We start at negative 2.143. We end at E99. The mean, since we converted it to a z-score, 0.1. And we end up getting the same answer, 0.9839. So again, you may ask me, well, why do I have to convert it to a z-score, then find the probability? This practice was in place back in the day before calculators became a thing. We used to make use of tables, and the tables were generated for z-scores and not for normal distributions with varying means and standard deviation. So back then, when we did not have the technology, the only way to solve the problem or solve a problem like this is to first convert the given x value to a z-score, find the z-score, then go back to the table. You could find that table in the appendix of any statistics textbook. It will say standard normal distribution probabilities, and you'd make use of the table to find the probability. But these days, we have a calculator, and we really don't have to take the step in converting x to z-score, then finding the probability. So here we want to find the probability that x is between 56 and 68. So 50 is the mean. So mean's right over there. And 56 is probably right there. I'm just guesstimating. Again, if you want to become an expert in knowing where to draw that vertical line, either practice more or go back and look at empirical rule for normal distributions. So 68 would probably be there. So 56, 68. And we want to find the area between those two values. So the easiest way would simply be to use the calculator, of course. So second last, number 2. Now we always use negative E99 and positive E99 as the starting and ending values. But if we look at this problem, the area, the shaded area, starts at 56 and it ends at 68. So the starting value would be 56. The ending value would be 68. The mean is 50. The standard deviation is 7. And even before I hit enter, I know that the answer is going to be under 50. Let's say if that is true. It certainly is. So when you're doing multiple choice, this is one way to do process of elimination. So the answer is 0.1906 or 19.06%. Now we have probability 40 less than or equal to x, less than or equal to 49. So the mean is again 50. And 40 is probably somewhere over here. And 49 is very close to 50. And we know the area or the answer that we're going to obtain should definitely be less than 50. So the starting or the lower value is 40, the upper value is 49. So in your calculator, second bars, start at 40, end at 49, mean is 50, standard deviation is 7, and the answer is 0.3666. Oh. So in all of the previous problems, we were given a percentile, and then we found the probability. What do I mean by that? The percentiles are simply all of these endpoints that we use to find the probability. So on the real number line, number 35 is a percentile, 40 is a percentile, 68 is a percentile. All of those are percentiles. So in the previous problem, the percentiles were given to us and we wanted to find the probability. Here, we want to find the percentile. So we have to go back and understand what a percentile is. So just as a refresher, the kth percentile is a value piece of k, so that k% of the data lies below it. So in other words, the probability of x less than or equal to pk must be equal to k, or k%. Or k of 100. What do I mean by finding piece of k? Again, if you go back and refer to the previous problem or look at 25 over there, so we have probability x less than or equal to 45. So here, pk in comparison to that problem would simply be 45. So we have to find a number so that the area below the number is equal to k%. So let's start with number 33. So problem 33, we want to find the 9th percentile. In other words, we need to find P9. What does P9 mean? P sub 9, simply probability x less than or equal to P sub 9 must be equal to 9% or 0.09. And that's what we need to do. So where do we start? We are given that the mean is 50 and the standard deviation is 7. Now is a good time to mention or bring up the empirical rule that I've been referring to for a while. So if you look at the empirical rule, the mean lies right in the middle. First standard deviation to the right, second standard deviation. Mean plus 3 times the standard deviation. Mean minus 1 standard deviation. Mean minus 2 standard deviations. Mean minus 3 standard deviations. And why is this so important? In our problem, we can write out these values. 50 is the mean. The standard deviation is 7, so 57, 64, 71. I'm adding standard deviations. Likewise, you have to subtract standard deviations on the other side, 43, 36, 29. So each of those numbers that we computed would actually correspond to a percentile. And refer to the empirical rule. I'll put a remark here. %50 lies below the mean 50. So that would be P50. 84% would lie below 57. 97.5 would lie below 64. 99.35 would lie, 85 would lie below 71. On the other side, the percentiles are P.15, P2.5, and P16. So those are simply the percentiles corresponding to the data. So data values and their percentiles. Now, why did I draw this? I drew this so that you can sort of guess the answer even before you start the problem. The first problem, problem 33, wants to know the 9th percentile. 9% has to lie below the number that I pick. If you look at the second vertical line on the left, the area below it is 2.5 because that corresponds to P2.5. The next one is P16, which would mean that 16% lies below P16. So P9 has to lie somewhere between P2.5 and P16. So I'm going to say perhaps it lies right over there. That is my guess, an educated guess about P9. Now, if you go back and compare it to the data, P2.5 is 36 and P16 is 43. So if P9 lies between P2.5 and P16, according to the graph that I drew, then the value that for P9 has to lie between 36 and 43, more so close to 36 than to 43. So let's see if I can make a good guess. I am going to say it is probably about 38.2. And let's see if that is true. What function do we use in the calculator to find percentiles? We use the inverse norm function in the calculator. The syntax is INV norm, the area below, the mean, followed by the standard deviation. Area below is the same as area to the left of the percentile. So my guess was that it is going to be somewhere 38.23. We will see. So I'm going to press second vars, and option number 3 is INV norm, stands for inverse norm. I need to put the area below P9. Since it is P9, 9% has to lie below P9. So the area below is 0.09. The mean, it's given in the problem, 50. Standard deviation, 7. And, well, I was close, but I didn't do a great job. The answer is actually 40.61. Does 40.61 lie between 36 and 43? Absolutely. So P9 in this case is simply equal to 40.61. In a similar manner, we can find P90. So P90 has to lie somewhere over here, because P84 is there and P95 is there. So P90 has to be somewhere between those two values. So the data points corresponding to P84 and P97.5 are 54 and 64. So the answer that we're looking for has to lie between 57 and 64. Let's take a guess and let's see if I can do a good job. I am going to guess about 61. Let's see if that is true. So the area below P90 is 90%, so 0.9. The mean is 50. Standard deviation is 7. Get 58.97. Looks like I'm having a bad day. P90 would simply be 58.97. Does it lie between 57 and 64? Yes, it does. And we can obtain that directly using INV norm. So what is the value of P82? So before we do that, there are multiple ways to guess the correct answer. One, empirical rule, like I did it. So P82 lies between the observation 50 and 57. So the answer has to be somewhere between 50 and 57. Okay, so if we want to find P82, we are trying to find a number that lies between P50 and P84, more closer to P84. So the guess is, 56. How do we find it using the calculator? Second mass. Number 3, area below is 0.82. Mean is 50. Standard deviation is 7. The answer is 56. .407, we can round it and write it as 56.41. If you have the newer version of TR-84, it should probably state area mean. It's either X bar or mu. It depends on the model. And sigma. The area here is simply, for example, P9 by 0.09. The mean would be 50 and the standard deviation is 7. So it's just the different layout with the newer models of the calculator.